Let's go to page 105, and this is lesson 2.5. And this lesson is about reason using properties from algebra. Okay, so you learn all this in algebra, but you can apply it in geometry also. Okay, so let's look at some of the key concepts. Okay. Before that, let's read through the paragraph. It says, when you solve an equation, use properties of real numbers. Segment length and angle measure are real numbers. So you can also use these properties to write logical arguments about geometric figures. So whatever you know in algebra, you can also apply in geometry. Okay, in algebra, you deal with numbers, but in geometry, you deal with pictures. But you can work the same. Okay, so over here, let's go and look at some of the property. So addition property, it says if A equal to B, then A plus C equal to B plus C. So what it's saying is that when you have equation, you can add same thing to both sides. Okay, so you can add C to both sides. Okay. And same thing, okay, so you can think about algebra, right? So subtraction property, when you have an equation, you can subtract same thing on both sides. So you can subtract, you can minus C on both sides. That's what it's saying. Multiplication, so you did a lot of this already in algebra. Okay, when you solve an equation, you use a lot of these properties. So multiplication properties, when you have an equation like A equal to B, then you can multiply both same thing to both sides. So you can multiply by C on both sides. Same thing with division. Okay, if A equal to B, then you can divide both sides by C. Okay, but remember you're not allowed to divide by 0, right? So C cannot equal to 0 because you're not allowed to divide by 0 because it's undefined. Okay, so substitution property. So if A equal to B, then A can be substitute for B in any equation, in any equation or expression. So if they're equal, then whenever you see B in other equation, you can substitute A for it. Okay, so again, those are the properties that you learn from algebra. So let's go and look at example. So example 1. Okay, write reason for each steps. So that's why, when we were in algebra, I always tell my students to show your step, do things step by step. It helps you think logically. So now when you're doing the geometry, you have to do that step by step, and you have to know the reason. Okay, so over here, so here's your original equation. So write down the equation. So that's giving. That's why it's giving. Okay, so now to solve these. First, we're going to add 3x on both sides because we're going to consolidate a variable, right? So we're going to move this over. So you add 3x on both sides. So that's your addition property, okay? Addition property of equality because you're adding same thing on both sides. So now this will cancel out, right? So you get that. So you simplify, okay? And then after that, we're going to, so this just simplify, okay? Combine the like terms, so that's just simplifying. Then from here, we're going to minus the 5. So that's going. So notice this will have additional step. Okay, so technically you can just go from here to here, and that would be the reason. Okay, so from here to here, you just add 3x on both sides. This one they come with additional steps, but actually you can just go from here to here. Just get rid of that. So from here to here, they just give you additional step in the beginning, so you know what's going on. So you add 3x. So addition property equality, you add 3x on both sides, you end up with that. So next step, from here to here, notice you have to minus 5 on both sides, right? So that's your subtraction property. So subtract 5 on each side to get to here. Then after that, from here, you have to solve for x, so you have to divide by 5, right? So divide by 5 on each side, so that's your division property, okay? And therefore, the value of x is equal to 3, okay? So make sure you understand the properties, okay? You already did a lot of this already, so this one should come naturally. Okay, now let's go to page 106, the distributive property. Distributive property means you got A times parentheses, B plus C, then you distribute. Okay, so this becomes A times B plus A times C. Okay, so you already did a lot of this in algebra. Okay, so now let's go over the example 2. Use the distributive property. So again, you want to solve this equation. So first you copy, so that's giving, right? So from here to here you distribute, right? You multiply. So negative 4 times 11x give you negative 44x. Negative 4 times 2 give you negative 8. So this is multiplying. So this is applying the distributive property. So next step is from here to here, you have to solve by adding the 8 on both sides. So plus 8 on both sides to get here. So that's your addition property, okay? So you add 8 on both sides. The next step is to solve for x, you have to divide both sides by negative 44. So divide by negative 44 on each side, so that's your division property. Okay? So again, these are the steps and these are the reasons. So basically, it's very common sense, okay? So if you're distributing, that's distributed. After that, you add, divide, right? Okay? Okay, so here's example 3. Okay, use properties in the real world. So that's going to be the rules of heart rate. It says when you exercise, your target heart rate should be between 50% to 70% of your maximum heart rate. Your target heart rate R at 70% can be determined by the formula R equal to, so formula R equal to 0.70 times 220 minus A closing parentheses, where A represents your age in years. Solve the formula for A. Okay, so first you write these things down, so that's given, right? The next thing is you have to go and distribute, multiply out the distribute. Okay, distribute, so that's multiple. So that's distributive property. Okay. So again, you're solving for A, right? So you have to move everything else to the other side. So next, okay, from here to here, you minus 154 on both sides. So that's how you move this over, right? So that's subtraction property, right? You minus 154 on both sides. Your next step is, again, you're solving for A. So you're going to divide by negative 0.70. So that's your division property. So the reason is very common sense. Whatever you do, that will be your reason. Okay. So if you subtract, there will be subtraction property. If you divide, there will be division property. If you multiply, there will be multiplication property. If you add, there will be addition property. Right. Okay. Okay. Now let's go to page 107. Okay, so properties. The following properties of equalities are true for all real numbers. Okay. And it says segment length and angle measurement are real numbers. So these properties of equalities are true for segment length and angle measurement. Okay, so let's go over some of the key concepts. So first one, reflexive property. So reflexive property is something that equal to itself. Okay, so first, the real number. So for any number, a number will equal to itself. Okay, so for any number, it will equal to itself. And the segment length, for any segment, okay, AB, again, so AB equal to AB. So again, length equal to itself. So this is talking about the number, then the segment, and then talking about angle. So they're just different dimensions, but the property works the same. So reflexive property talking about something will equal to itself. So when you have a number will equal to itself. When you have a segment will equal to itself. When you have an angle, the angle will equal to itself. Okay. The next thing is the symmetric property of an equality. This is like when you have something, you flip it over. Okay. So if you have A equal to B, then when you flip it over, you get B equal to A. So same thing over here for the, notice you have three, a set of three, right? You have the number, the length, and the angle, right? So they work the same. So if you have a number A equal to B, then when you flip it over, then you still have B equal to A. So it's still true. The segment, if you have AB and CD, if AB equal to CD, then when you flip the equation over, you got CD equal to AB. So when you flip over equation, it's still true. Okay? And same thing, when you have measure of angle A equal to measure angle B, when you flip the equation over, you get measure of angle B equal to measure angle A. So it's still true. Okay, now transitive property is almost like a domino. Remember we did that we did that earlier to prove like the synergism, right? So again, think about domino, right? If A go to B and B go to C, then A go to C, right? Because you link up the B and the B, right? Okay, so A go to B and B go to C, then A go to C, okay? Just like a domino, right? So that's for the number. So if that's a number, then the length and the angle will be still true, right? If AB equal to CD and CD equal to EF, then AB will equal to EF, okay? Because I can link it up, right? Think about the domino effect, right? Okay. And same thing for angle. If measure angle A equal to measure angle B, and measure angle B is equal to measure angle C, then measure angle A will equal to measure angle C. Okay, so you can just think about the domino effect, right? Okay. And to make it more clear, okay, another way to see these, okay, if you don't see it clearly, then what you do is look at the link. Okay, so like this one here, if A equal to B, right, and B equal to C, so by link it up, you can see that A equal to C. Okay, that's kind of, this way is kind of easier to see. Okay, so same thing over here, right? If you have a AB equal to CD, right, and you have a CD equal to EF, right? By link it up, see, then you can see that AB equal to EF, okay? So same thing with the angle. So by writing it this way, it's easier, it's more clear to see, okay? Okay, let's go to example 4. Okay, so you are designing a logo to sell daffodils. Using the information given, determine whether measure angle EBA, so EBA is equal to measure of DBC. So this one is equal to that, okay? Okay, so first, okay, it's giving, so measure angle 1 equal to measure angle 3. So it's giving, they're equal because see the little arc over here, the marking, okay? See the little marking right over here? So this tells you that angle 1 and angle 3, they are congruent, okay? So again, the explanation is given because it's the marking in the diagram, okay? And next, we're going to use the angle addition. So angle EBA, so EBA, that's the angle 2, okay? So you can also use, so the angle 2, EBA, yeah, EBA, this over here. So angle EBA is an angle 2 plus angle 3, right? See that angle EBA equal to angle 2 plus angle 3. And angle, and since they are congruent, we're substituting. See that 1 and 3 are equal, so we can substitution. Okay, so we switch angle 3 to angle 1 by using the substitution. Okay, and then also just by looking at the diagram, right? See the angle 1 and angle 2. Angle 1 plus angle 2 equal to CBD, right? Or DBC. Okay. So this is the angle addition postulate, right? So again, the part 1 plus part 2 equal to the whole thing, right? That's what the angle addition postulate is, okay? Then after that, again, we're going to do the substitution, okay? So you can call it substitution or transitive, okay? Either one is going to work, okay? So since EBA equal to 1 plus 2 and 1 plus 2 equal to these, so again, the transitive means like the link, okay? Like this one over here, the transitive, okay? So by doing the linking, so remember what we did, right? So this equal to that, and this equal to that, so you link them together like domino. That's called a transitive. So transitive, think about dominoes, right? You link them together, okay, and that's your transitive property, okay? Okay, let's go to example 5. Use property of equality. Okay, so again, you have this picture. So in the diagram, AB equal to CD, so that's the marking. See the marking shows that equal, right? You want to prove that AC equal to BD. Okay, so first you always start with giving. Okay, so you always start with giving. So giving AB equal to CD. Okay, so that's marking. You know that they're equal because the marking is giving, right? Okay, the next thing is write the AC. See over here, look at AC equal to AB plus BC. Okay, that's the segment addition, right? Again, addition partial means you got the first part plus the second part equal to that sum, okay, or the whole thing. And then you have the BD equal to BC plus CD. So again, the same thing, segment additions, okay? Then next, okay, what you can do is you're going to add so over here, right? See the AB equal to CD, right? See over here, from here to here, you're going to add BC to both sides, okay? So see from here, you add BC to here, you add BC to here. So that's your addition product equality. So this one came from here. So right now they put these two on hold for a while, okay? So from they go back to the giving, and you add both on the you add BC on both sides. Okay, now once you do that, you can do the substitution. Notice AB plus BC, see AB plus BC equal to AC. So this becomes AC. And from here, BC plus CD equal to BD. So this becomes BD. So there's substitution. Okay? And then that's it. That's your conclusion. That's what you want to prove. Okay? So you always start with something that's giving. And then from there, you can use other postulates and you can do the substitution or whatever. Again, the way you do the geometry proof is same way as you would try to solving the equations. Okay, you do it step by step and you give the reason using those postulates.